Welcome back. Now that we have our 5 statements down, we're going to look at a couple more reasoning techniques. The first one we're going to look at is deductive reasoning. We're going to use the law of detachment or the law of syllogism in deductive reasoning. Now, if we look at this, an example would be if Joe goes to the ball game, he will not go to the movies. Joe went to the ball game, what conclusion can you draw? Well, if you look at this, you can see if Joe goes to the ball game, he will not go to the movies. Joe went to the ball game, therefore he will go to the movies. You're using that to decide if he will go to the movies. If you look at the second one, if Kay goes to the ball game, she will not go to the movies. Kay did not go to the movies. Can you conclude that Kay went to the ball game? In this case, you cannot conclude that because just because she didn't go to the movies doesn't have anything to do with going to the ball game. So that hypothesis and then conclusion in that order is what you're looking for. That conclusion has to follow that hypothesis. So we would say no conclusion or no. Unlike inductive reasoning where you're looking at a bunch of examples and coming up with the next conjecture, in deductive reasoning you're looking at a main idea and then deciding if it's true or not based on that. So that's our method of today, deductive reasoning. As I mentioned in 2.1, we learned that one counter example is enough to disprove a conjecture. But to prove a conjecture is true, you must use deductive reasoning. Okay, so to prove inductive reasoning false, you need a counterexample. In this case, we want to prove a conjecture is true, we need to use deductive reasoning. We're looking at a couple of different examples. 2 laws that we're going to use. We're going to use the law of detachment and the law of syllogism. Both cases we will reach conclusions based on if-then statements. So those conditional statements are what we're going to be looking at again. Law of detachment. Whenever a conditional, okay, again, an if-then statement is true and its hypothesis is true, we can conclude that its conclusion is also true. So if you know something's true in the hypothesis and then the conclusion happens, that conclusion must be true. So if we look at a couple of simple examples, if you went to Butler University, then you lived in Indiana. I went to Butler University, or Tim went to Butler University. We can conclude that I lived in Indiana. I was at the school, so I had to be living there. So again, if you went to Butler University, then you lived in Indiana. Tim went to Butler University, so then therefore I live in Indiana. If you live in Florida, then you must be prepared for hurricane season. Tammy lives in Mississippi. Okay, that has nothing to do with what you're looking at. That's a different hypothesis. We have no conclusion to match that hypothesis, so we have no conclusion. Okay, so we cannot always draw a conclusion based on the given information. So we have to look at what we have and make sure we're following that hypothesis. Second thing is the law of syllogism. Okay, in this one it's kind of like whether you learned it as like the commutative property or however you learned it back in the day. If P then Q and Q then R are true, then P to R is true. So if P happens, then R is true. So it's kind of like that Q or that conclusion in between is connecting those two pieces. So what I mean by that is if we look at an example, if while he goes to the movies, he will go to bed late. So we have while he goes to the movies, so that's our P. We have he will go to bed late, that's our Q. While he goes to bed late, that's our Q again, because they're the same things that we're talking about. And then we have he will be tired in the morning, which is our R, whatever letters you want to make them. So if P, then Q. If Q, then R. Now, if we're looking at this question here, while he goes to the movies, what can we conclude? Well, that Q piece is connecting these two. So if P, then R. So in other words, if while he goes to the movies, we can conclude he will be tired in the morning. Okay, so again, I use a color-coded system. You can use an underline system to help you. Whatever works. Okay, so we have both of these laws. We're going to look at a quick example of each of them so that you understand what each means and how to use each. So again, look at that law of detachment. If it's a fish, then it will swim. Nemo is a fish, then we can say that Nemo will swim. Okay, so they're being connected there. Law of detachment. Law of syllogism, that's where we have our connecting Q kind of piece that will hopefully connect two pieces. So again, when Jack gets road rage, that's our P. His face turns red. That's our Q. When Jack's face turns red, there it is again. That's our Q. He looks funny. Okay, something totally different. Now, again, we have these two connecting pieces, the face turning red. So when we look at this, when Jack gets road rage, he looks funny, would be our conclusion. Okay, so you have both examples. They're a little bit different here. Okay, so we look at a couple examples. I'm going to go over one or two of these with you, and then I'm going to give you guys a chance to work on a couple of these today, and then again tomorrow in class. So, determine if statement 3 follows from 1 and 2 by the law of detachment or the law of syllogism. So you have to just decide which one is working here. So, if you break an arm, or if you break an item in the store, you must pay for it. Okay, Jill broke a vase in Potter's gift shop. Jill must pay for the vase is our conclusion or our statement following those. Therefore, if you look at it, it looks just like the one we did with the law of detachment. There's no connecting piece or no connecting R that we need in this case, so it's not the law of syllogism. Look at the second one. If you are in geometry class, you are a math student. If you are a math student, so again, we have our if P, then Q, and we have if Q, then you have a pencil. We all know you're supposed to be using pencil, so we have our random thing thrown in here, but again, they're being connected by this piece. So if you're a geometry student, you have a pencil. That's using the law of syllogism. It has that connecting statement in there, which makes this true. Okay, this group work, I'm going to get you guys started on the first two. You guys can try the rest if you want to come prepared before, but I will be checking to make sure you followed at least through 1 and 2, and then I'm going to have you guys do 3, 4, 5, and 6 tomorrow in class. So determine if a conclusion can be reached from the two given statements using the law of syllogism or the law of the law of detachment or the law of syllogism. If a conclusion is possible, state the conclusion. If a conclusion does not follow, state no conclusion. Okay, so let's figure out what's going on. If a number is a whole number, then it is an integer. So we have if P, then Q. If a number is an integer, there's our connecting P, so here's our Q again. Then it is a rational number. Therefore, our conclusion we can make is if P, then R. So we can say if a number is a whole number, then it is a rational number. Okay? If we look at our next example, if a dog eats dog food delights. Okay. If a dog eats dog food delights, the dog is happy. Fido is a happy dog. Okay, so now we have no connecting piece. We have if P, then Q, but now this next piece we would need is the dog is happy, then something happens. We don't have that. All we're saying is Fido is a happy dog. We're using a conclusion in the statement. We don't know that for sure that's the reason he's happy. It could be for he went for a walk, he just got fed, who knows what it means, but just because he's a happy dog doesn't mean any of this happened. So we can't draw a conclusion from that. I'd like you guys to try number 3 before you get to school. So make sure that one's done before class tomorrow. I'll check that one. And then 4, 5, and 6 we will do together. So I want you to try 3, see what you can figure out with it, if you can draw a conclusion or not, and then bring that for class tomorrow. Peace.